Here we go with our first video notes. All right, we're talking about variables and expressions. This is very similar to yesterday's lesson, lesson 1-2, but we're just throwing some letters in there. All right, you'll be doing the same thing. You'll be translating verbal phrases into algebraic expressions. Well, yesterday you just changed them into expressions. Now we're going algebraic, which means they have variables. Evaluate expressions containing variables. Evaluate means to substitute out the variables for numbers and simplify using order of operations. All right. Our essential question: how can you use numbers and symbols to represent mathematical ideas? All right. So we'll get started. We know that algebra is a branch of mathematics that uses symbols. A variable is often used in algebra. Variable is a letter used to represent an unknown value. All right, these are all in your Quizlet. If you feel it necessary, you notice that it's easier if you write them down. That helps you study. Please do that. Otherwise, just study them on Quizlet. Now, we have algebraic expressions, different than numerical expressions. Numerical expressions only have numbers and operations. Algebraic expressions have at least one variable. All right, and here it says also at least one mathematical operation. So we want to focus first on translating verbal phrases into algebraic expressions. One of the big steps here is defining a variable. So when there's some sort of unknown that we don't know a number for it yet, we're going to want to define that unknown. We want to give that unknown a variable to represent it. All right, so excuse me. So we'll look at how that works shortly. All right, here's a little process that we're going to use to get from words to our algebraic expression. Okay, you can basically summarize a word problem or something that could be written in an expression. Summarize it with just the most important words. Then we define our variable, choose what unknown quantity do we need to represent as a variable, and we define it. And then we finally take that information and change it and write it all really concise into an algebraic expression. Sounds like fun. Let's do it. All right, so you can see the examples of how they did it. Example 1, $3 more than the cost of a sandwich. $3 more than a cost of a sandwich. So what is the unknown here? So here's the words. $3 more than the cost of a sandwich. So a sandwich, we don't know how much that costs. So we're going to let C represent the cost of a sandwich. And then we have an expression 3 plus C. Now, I do not like the order they put this in. I would much rather, whenever you see more than or less than, you take this value that's in the beginning and the value that's at the end, and you flip-flop them. Okay, 3 more than the cost of a sandwich. I would prefer it written as C plus 3. It matters more when we're talking about subtraction and like 3 less than. All right, that has to be at the end. But I like to be consistent with less than, more than, and just throw that number at the beginning, put it at the end. So you could, I guess you can't write in your books, but just make a mental note of that. Okay, here we go, part B. Mari had $2 and made $6 an hour babysitting. You might read that first and be like, there's no unknown. It told you everything. All right, well, the thing is, there was no question. They didn't ask a question, so it is a bit confusing at first. But if you think about it, you don't know how many hours he was babysitting. So $6 an hour, well, for how many hours? So if you wanted, I guess it would be helpful if they said, what is the total amount of money he made? Then that would help you realize, wait, I don't know how many hours he babysat, and that would be our unknown. But just how they have it written, not my favorite. All right. Anyway, 2 more than $6 per hour. Well, we're going to define the number of hours as n in this case. So we're defining our variable, that important second step. And then we have 2 more than $6 per hour. So 2 more than 6 times the number of hours, right? And I would prefer, again, to make that 6n plus 2, right? Because of that more than phrase. More than and less than, we take the number that starts it off and put it at the end. All right? You can read over this, pause and read that. It's this idea that typically we write the number before the variable when we have a product, when we have a multiplication monomial there. All right? Or term. Okay. Go ahead and pause. Try 1A and try 1B, and then come back, unpause, and check to see how you did. All right? Pause. All right. Hopefully you paused and didn't just blow right through it and just expect me to do everything for you. But anyway, let's see how we did. 2 miles less than the athlete ran. All right. Well, 2 less than the athlete ran. So that would be the words. Then we're going to do the variable. So we don't know how much the athlete ran. So let's let A represent how far the athlete ran. I'm just writing shorthand to make it quicker. So A is going to represent how far the athlete ran, and 2 less than that. Now this is that less than phrase that I've been trying to help prepare you for. You can't write like this, 2 minus A, right? That would not make sense. We need to do A minus 2. That less than phrase can be tricky if you don't pay attention. Okay, A minus 2. Let's go to 1B. All right, 1B. 5 points more than the points scored by field goals if each field goal is worth 3 points. So I'm guessing they want you to figure out the total points scored. All right, so we're doing 5 more than the points scored by field goals. So I would say 3 times the number of field goals. Okay, 5 more than 3 times the number of field goals. Or I guess you could say something like 5 more than the total points scored from field goals. I'm not sure how to write that, but this gets the point across. All right, we have 5 more than. Okay, so what don't we know? We don't know the number of field goals. So we're going to have to represent the number of field goals with a variable. So let's go F for field goals. Let F represent the number of field goals. Okay, and now we can say 5 more than, that tricky phrase, put that at the end, and then 5 more than what? Three times the number of field goals, which we represent as F. All right? 3 for every field goal. All right, moving on. Okay, we had some practice there. Now we're going to start evaluating expressions, algebraic expressions. All right, and here we have the substitution property of equality. If two quantities are equal, then one quantity can be replaced by the other. Makes sense, right? It's kind of like, I don't know if you've ever watched um, Raiders of the Lost Ark. I think it is. It's one of the Indiana Jones movies where he's looking for the treasure, and he has to replace like there's this idol on the stand, a golden idol, and he has to replace it with something the exact same weight, or else all the booby traps will go off and he'll certainly die or something. And so he like real quick swaps it out, and everything looks fine. Everything looks fine, and then boom, he sets off all the traps, and he has to run and escape. Anyway, if you remember that, it's kind of like substitution property gone wrong because they weren't quite equal, so it didn't quite work. But in this case, the book's going to tell you that two things are equal, and you just have to trust them. Hopefully, while you're doing this, you don't set off any booby traps that could destroy everything. All right. So substitution, right? Here's the symbols. It says for all numbers a and b, if a equals b, then a may be replaced by b. Okay, so as long as you know something's equal to something else, then you can take the one thing out and put in the other thing. All right, so let's roll. Let's check out these examples, and we'll do them quickly because I think you guys will be all right with these. Okay, so it'll say evaluate and then give you an expression, and then they tell you what are equal so you can substitute. So if D is equal to 16, then wherever there's a D is, you can put a 16. If F is equal to 18, wherever an F is, you can put an 18. All right, so here you go. They show this, I like to call the goose method. Kind of looks like a flying goose. Check it out. You got that, honk. And then he's like got his wings down. You see, both wings. And then that's his little tail there. Oh, isn't that cute? Like when they put both their wings down. See, I am a great artist. Even better when I'm using a trackpad to draw. You see, his wings are down right now, but then they'll flap up. It's like you can see his little neck there. Okay, I call this the goose method. You write the original over here, you substitute to the right, and then you work down in a triangle, simplifying using order of operations. All right. So there you go. You substitute to the right, and then you take one step at a time. Do the addition. You do addition and subtraction at the same time, moving left to right. So you do the addition first since it's further left, and then subtract, and you get the 3. All right. Try 2A and 2B. Pause, and then jump back on and see if you're right. All right. Let's go to A. Let's see if I'm going to evaluate that. I'm going to write the original. 6 minus e plus f, and then I'm going to write the same expression, just with everything replaced, all the variables replaced with what they're equal to. So that's going to be minus 3 plus 9. I'm going to do my addition and subtraction left to right. So I do that first. I get my 3 plus 9 equals, there we go, 12. All right. So I evaluated that expression. On to the next one, 7k plus h. Now I'm going to substitute. So I get 7 times 4 plus 10. Now what operation goes first? I like to use gems. So multiplication and division, subtraction and addition. So multiplication and division goes first. That gives me 28 plus 10. And simplify 38. How'd you do? 2 for 2? I'm guessing that you did. Hopefully, find your mistakes if you didn't. And we should be getting to the end pretty soon. Now, I'm going to have you study these pretty much on your own. All right, you can see this example where we have 2 sets of multiplication. You do those both first and then add the results. Over here, remember that the division bar acts as a grouping symbol. So it makes two groups. It makes a group at the top, those are supposed to be parentheses, and a group at the bottom. Now, you don't have to do anything at the bottom, but just so you know. Okay, so they wrote it like this. So top goes first. Top dog gets first place. Divided by 20. Substitute. I will often write it like this. ST over 20. And then I'll just keep it in a fraction and put the 5 times the 8 all over 20. Work down. Now we substitute. We work on the top, which 5 times 8 would be 40. And then we get 40 divided by 20 is 2. I like to leave it in fraction form, but you're welcome to change it to the division form that they have over here. Okay? Oh, C is so cool. Look at all those operations. We got parentheses. Amazing. All right, so you substitute, follow order of operations, you go in the parentheses. Whenever you go inside parentheses, you basically start order of operations over again. So make sure you do the multiplication here, then subtract, and then you can add outside the parentheses once you get rid of those parentheses. All right. Okay, try these ones, pause. I'm just going to pop the answer up instead of doing them all for you. All right, I have a special button that allows me to do that. Okay, pause. All right, you should have done them. I'm gonna show you the answers. There you go. So 3A is 36, 3B is 2, and 3C 44. All right, now we're gonna move on to our final example. Words. Let's see. It says a company rents a houseboat for $200 plus an extra $30 per day. So we're gonna write an expression for this. Now, it actually tells us in this case what we're looking for. So it says write an expression that can be used to find the total cost. Thanks. That gives us some guidance, unlike the ones that they started us off with. All right, so if we know that we're looking for the total cost is $200 plus $30 per day, what's the unknown then? The unknown is going to be how much per day. So here's a little summary of the word problem. Then down here, we know that how many days is our unknown, so D is going to be days. And then it looks like we're going to do 200 plus 30 times the number of days to write down an expression to represent that total. All right, and then the second part of the question says, suppose the Gregorin family wants to rent a houseboat for 6 days. Well, now they're just telling us that the D is going to be replaced with 6. What will the total cost be after 6 days? So you can simplify that, and boom, you got the answer. All right, try number 4 on your own. Pause while you do that, and then unpause to check the answer. All right, hopefully you did it. Here comes the answer. All right, make sure you let me know if you had questions. I would love to help you with whatever you had problems with. Hopefully you're good to go and you understood it well. All right, thanks.